So we are currently at the water treatment plant of IIT Kharagpur. So the reason of visit is we are going to test our edge device, which is capable of identifying possible faults inside the motor non-invasively, and we are going to achieve this just by collecting a single phase current data of the induction motor. So this is the pump house inside the water treatment plant. So here there are several number of motors are there. So we'll be connecting at a single motor to identify its possible failures. So this is inside the pump house. So you can see there are several induction motor setup connected. So we will be carrying out our experiments on the pump number 7. So it is not currently operating. So this is pump number 7. It is 45 kilowatt induction motor, 60 HP. Now I'll zoom on the nameplate to see the exact details of the motor. So you can see the exact details of the motor here. So it is a 77 ampere, 93.1% efficiency rated, and the bearing used here is 6313ZZ, and almost it is 45 kilowatt and 60 HP. So it's a Kirloskar manufactured induction motor, and the rated RPM is 1470, and the input supply is 415 volt. This is all about the nameplate. Now we'll see how the motor is getting operated. This is the panel for the pump number 7. So you can see currently the motor is not operating. So if I open the panel, so this is inside the panel, you can see. So you can easily see the 3-phase input to the motor and the VFD connected. So we'll tap on one phase of the motor and collect the current signature data and verify the possibility of fault presence inside the motor. Now you can see the motor started operating, and we'll capture the current signature now and identify the possible fault presence and the current operating condition of the motor in the edge device. So this is our edge device. Now you can see, so this edge device have two parts. One is the signal conditioning circuit and another is the edge where the Raspberry Pi is connected. So the Raspberry Pi handles all the computation and all the algorithms that are deployed currently in this device, and it will estimate what is the rotor slot harmonics. Then it will derive the sleep, speed and the efficiency the motor operating at, and it will also detect various kind of fault that are currently present inside the motor. So now you can see this edge device is connected to one phase of the pump 7 motor panel, and it will only capture single phase current sensor data, and the processing will be done at the edge. So after the edge device collected the data, it will analyze the same current signature at the edge, and it will identify present operating condition of the motor and the fault presence if any. Now this data is pushed to the cloud server, where we are connecting this visualization dashboard to see all those parameters in a form of health card. So this is the motor condition monitoring dashboard. If you log in on this dashboard, as a user I will log in and I will go through my user credential. After putting my credentials, I will submit it, and I will arrive at a dashboard where the motors are classified into 3 types. The motors which are under the working conditions, motors that got developed the fault but currently operating, and the third type is motors that are not working due to the arrival of any fault. So we'll directly go to the list of motors, and there will be number of motors that are connected presently are shown here, and motor type, and similarly each motor have different health card and the historical graphs as well. So the current motor in the pump house is motor 201, and if you'll see its health card, you will see the recent data the edge device is pushing to the cloud server. Now the current motor is currently operating at 37.5 ampere, 50 Hz frequency, and the sleep that is estimated from the current signature is 0.01. Then the speed of the motor is currently 1481.74 rpm, and the motor is operating at 95.4% efficiency, and the edge device detected a presence of static eccentricity fault in the motor, and the timestamp and the date of when the fault had detected is also updated in the health card of the motor. So you can see the different faults that are coming, and with timestamp it is getting updated in the recent data folder. Now if you go to the summary and recommendation, it will show the last fault that got detected and the current condition, whether the motor is currently operational with the fault signature or the motor is currently in the failure mode. And it will also give you an idea about the approximate remaining useful life of the motor. So it is currently 344.75 days. This RUL model is at the cloud. It analyzes the current signature and estimate the remaining life of the motor. Similarly, we will have a fault summary table that will show various kind of fault that had already occurred in the motor in the last 1 week, last 1 month, and the last 1 year time frame. So you can see the current motor is eccentricity fault and it had been detected 12 times. If you come down, it will show the recent motor current signature data that is streamed from the edge device. So that is 37.5 ampere the motor is operating, and also it will show the motor frequency, and similarly it will also show the motor efficiency. Now we have a provision of generating a report, that is the remaining useful life report. So in the report itself, you will see the current motor operating condition and the recommendations and different fault signature data. So in the summary report, you will see the current condition of the motor is operational with fault signature, and the fault detected is eccentricity fault, and the remaining useful life of the motor that is getting detected is 34.75 days.